Welcome back to G Fun Facts Online, your go-to source for the coolest science and tech breakthroughs. Today, we're diving deep into a solution that sounds like something straight out of science fiction, but is very much a reality: pulling fresh water right out of thin air. We all know freshwater scarcity is a huge global challenge, affecting millions. But what if the air around us held the key? That's where atmospheric water harvesting, or AWH, comes in. This incredible technology aims to capture water vapor from the atmosphere, offering a lifeline, especially in dry regions or places with limited clean water access. Scientists and engineers are constantly innovating, making these systems more efficient, less energy-hungry, and ready to scale up. So how exactly do we catch water from the air? There are a few fascinating ways. First up, we have sorption-based systems. Think of these like super sponges. They use special materials called desiccants that absorb or adsorb water vapor. And the materials themselves are getting seriously advanced. We're talking metal organic frameworks, or MOFs. These are like microscopic honeycombs with enormous surface areas, perfect for grabbing water molecules even when humidity is low. Cool new MOFs like MOF 303 can even be regenerated using just sunlight. Then there are hygroscopic salts, like calcium chloride, which naturally suck up moisture. Scientists are embedding these into stable composite materials to boost their water-grabbing power. We also have hydrogels, polymer-based materials that can soak up massive amounts of water. Some of these are thermoresponsive, meaning they change how much they like water based on temperature, making it easier to capture and release the H2O. And if that's not cool enough, researchers are even looking to nature for inspiration, mimicking desert beetles and cacti that are masters of water collection. Imagine nanofiber meshes, infused with zeolite or micro-patterned films designed to maximize every tiny droplet. Beyond the materials, the design of these systems is also getting smarter, with things like fin-array adsorption beds that improve water capture and reduce resistance, all aiming for faster cycles, often powered by the sun. Next, let's talk about cooling condensation systems. This is a bit like the condensation you see on a cold drink on a hot day. These systems cool the air below its dew point, forcing the water vapor to turn into liquid. The big focus here is on efficiency: better refrigeration cycles, eco-friendly coolants, and smarter airflow to cut down on energy use. Surfaces are also getting an upgrade with hydrophilic coatings that attract water, and microgrooves inspired by those desert beetles again, helping collect water using gravity. No extra pumps needed. A really exciting innovation here is radiative sky cooling. This is a passive trick where special surfaces radiate heat out to the cold of outer space, especially at night. This cools them down enough to cause condensation without needing any external power. Imagine materials that are great at emitting infrared heat but don't absorb much sunlight, built into designs like vertical double-sided panels. Then there's fog harvesting. This is a bit more straightforward, using meshes to intercept tiny water droplets from fog. But even here, there's innovation. Instead of just basic nets, researchers are developing fog harps with ultra-thin parallel strings that are much more efficient at capturing that misty moisture. Now, beyond these specific methods, there are some big trends shaping the future of AWH. A huge one is integration with renewable energy. Think solar panels powering fans and condensers, or even using solar heat to release water from sorbent materials. Wind power can also help by boosting airflow. This makes AWH systems sustainable and perfect for off-grid locations. There's also a big push for passive systems, designs that need little to no external energy. Smart materials are also key, like those thermo-responsive polymers that adjust to temperature, making the whole water capture and release cycle more efficient. And of course, scalability is crucial. We need systems that can work for a single home or an entire community. Water quality is also a big consideration. While AWH can produce very pure water, keeping it clean is vital. So many systems include filtration and disinfection. Finally, tech like machine learning and climate models are being used to figure out the best places to deploy these systems, based on local humidity, temperature, and air quality. Now, it's not all smooth sailing. Challenges remain, like the high energy use of some active systems, the cost of these advanced materials, and the need to produce even more water, especially in super arid places. Scientists are also thinking about the long-term environmental impact if we start pulling massive amounts of water from the air. But despite these hurdles, the pace of innovation in materials, science, system design, and energy integration is incredible. Atmospheric water harvesting is rapidly moving from a futuristic dream to a practical, impactful solution for global water scarcity. It's a testament to human ingenuity and our drive to solve some of the world's biggest problems. That's all for this episode of Fun Facts Online. What do you think about harvesting water from the air? Let us know in the comments. Don't forget to like, subscribe, and hit that notification bell so you don't miss our next dive into amazing science. See you next time.